Hey everyone, welcome back to the Foundations and Pre-Calculus 10 videos. In this video, we're going to look at Lesson 3 from Chapter 2, which is looking at the sine and cosine ratios. So just as a quick recap, the other two primary trigonometric ratios are the sine and cosine ratios. So let's first talk about the sine ratio. So we use the sine ratio when we are working with an angle, the opposite side, and the hypotenuse in a right triangle. So suppose our angle was down here in the bottom. So when labeling our triangle, we're always going in reference to that angle. And just as another recap, remember your opposite side and your adjacent will change depending on where your angle is. So in this case here, the opposite side is opposite to the angle. So to identify that, I start with my angle and I go across from it. And that one there is my opposite side. Then the hypotenuse is across from the 90-degree angle. So if I have my 90-degree angle, go across, and here's my hypotenuse. So according to the sine ratio, we have sine of some sort of angle theta is equal to your opposite over your hypotenuse. So we would use the sine ratio when we're working with an angle, the opposite side, and the hypotenuse. So that'll be one reason why it's really important to label our triangle before we even start doing any kind of work, because we'll have to figure out which ratio we're using. So let's look at the cosine ratio now. So when we use the cosine ratio, this is when we are working with an angle, the adjacent side, and the hypotenuse in a right triangle. So say I have a right triangle and our angle is down here in the bottom. So labeling our triangle, the adjacent side is the side that's connected to your angle that is not the hypotenuse. So that is going to be this side right here. So that is your adjacent, because across from the 90-degree angle is your hypotenuse. So it almost might be easier to label your hypotenuse first, then your adjacent. I just find that a lot of students sometimes have troubles labeling that adjacent. So anyway, so according to that cosine ratio, we have the cosine of some angle theta is equal to your adjacent side divided by your hypotenuse. So depending on what type of information you're given, will determine which ratio you're using. So just remember with cosine, it's your adjacent and your hypotenuse. If we have the sine ratio, it's your opposite and your hypotenuse. So step number one in any kind of question is always to label your triangle. So now we're going to look at a word problem, which is example number 3 in your notes. So an observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. Determine the angle of elevation of the plane measured from the observer. So what we're going to do first here is we're going to draw a picture of what this looks like. So we have some observer. I'm going to represent him as a little dot there. And he's going to be looking up at some plane which is up top here. So here we're talking about the height of the plane. And then this is the horizontal distance away from the observer to the plane. This here will be a right triangle because here we're dealing with the height, which we know is always perpendicular, or creates a 90-degree angle with your ground or the horizontal. So to fill out our information, it might be easier to just go back and reread the problem. So an observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water. So this one here tells us the height. So this here is 300 meters above the water. And it's 430 meters away from the observer. So here's really important. Here it's saying it's 430 meters from the observer. So here we're talking about this diagonal distance here. So this here is 430 meters. So don't be confused, because some people might think that that's your horizontal distance. But in the question, it would say the horizontal distance away from the observer is 430 meters. But in this case here, it just says the distance from the person straight to the plane is 430 meters. So here we're talking about that hypotenuse in this situation. So then we're trying to find the angle of elevation, And so we're talking about the angle of elevation. We're looking for the angle that looks up, because here we're looking at elevation. So we start from some sort of horizontal line and it goes up. So we're looking for this angle right in here, which I can label as theta. Then, to figure out if we're using the sine ratio or the cosine ratio, we need to label our triangle. So, as I said, your first step typically is always easiest to label your hypotenuse, because you find your right angle, you look across from it, and that is your hypotenuse. Then the next easiest one to label is your opposite, because you find the angle and go across from it, and that is your opposite. Then if you like to, the other side here is your adjacent, but you don't need to label that since we don't actually have numbers for it. So here we have our opposite and our hypotenuse. So looking up at our ratios, I want to see which one has your opposite, which one has the hypotenuse. So here we have the opposite and hypotenuse right here, which means that we're using the sine ratio. So then, as always, I'm going to start by writing out my formula. So you have sine of theta is equal to your opposite over your hypotenuse. And then I'm going to fill in what I know. So I'm looking for the angle, so I'll leave that as theta. But my opposite is 300, and my hypotenuse is 430. So just like what we did with the tan ratio, we want to get theta here by itself, so I need to move sine over. So to move it to the other side, I have to do that opposite operation, which is sine inverse. So you have sine inverse of this entire right side, so I'm going to put that in brackets. And just remember, I like to save my calculator work until the very end, just that way I don't run into any rounding errors. So here we've solved for theta, which means that we can go ahead and plug this into our calculator. So when you're plugging that into your calculator, your buttons will likely be second function, and then sine, which should show up as sine inverse on your calculator, and then open bracket, 300 divided by 430, close your brackets. Once again, make sure your calculator is in degrees, so you should have a capital D EG, or even a capital D RG, or else you'll get the wrong answer because your calculator will be working with other units that we call radians and gradients, so then you'd get the wrong answer. Some of you might also have backwards calculators, so you might need to put this fraction first. So it'll be really important to always stick with the same calculator so you get used to how to work it, because they all kind of work a little bit differently. So when you plug this into your calculator, you guys should find that your angle is 44 degrees. And then because this is a word problem, we need to answer this with a sentence. So you could say the angle of elevation to the plane is 44 degrees. So that is everything here for this video. If you guys have any questions, make sure to come see me in class, or you guys can text me on Remind 101. And thank you guys so much for watching.